Hey coders, Darren here, continuing the 8-directional character system. Now many of you have been asking me for a long time now how to handle slopes and uneven terrain, and today we're going to find out. We'll also learn how to set maximum non-traversable slopes, so let's go ahead and list some requirements for this system. We need to be able to run up and down slopes, we should always be able to run down slopes but not always up them, and we should fall if we are not grounded. So if you haven't seen the last tutorial, let's go ahead and do a little bit of a recap of what we have. We have this 8-directional character system. The camera can rotate around the character system, and the player will be able to use the WASD and arrow keys to move relative to the camera's orientation. So no matter where I'm rotated, if I press W, I'll always go forward away from the camera. So if you want to know how to do that, check out the last tutorial. But today we are going to be focusing on climbing slopes with this character system. So let's jump into the code and see what's going to be required. Now for the slope check, we're going to have some sort of grounded boolean. So we need some variables to check if we're grounded. We need something called height. That's going to be the height of our character. Of course, this should be adjustable because depending on the character that we're using this controller with, the size of that character may be different. So we'll also have a height padding. Now this is really going to be adjusting for the Unity engine physics engine error. We'll talk more about how the error will cause some jitter a little bit later in this tutorial. So we need that height padding to take care of that. We'll also want a layer mask so we know what ground is. We know what to check for when we're asking if we're grounded or not. We'll have a public float for max grounded angle or max ground angle. So this will be the value of the maximum angle of ground that we're allowed to walk up. So we can initialize this to probably something like 120. We'll also have a public bool called debug, and this is going to determine if we want to draw some debug lines, because what we're going to be doing to climb slopes is modify our player's forward angle, and we want to be able to see that vector, or the forward vector, sorry. We want to be able to see that vector from the Unity editor. That's going to give us some useful insight. So we'll go ahead and add a private ground angle. That's going to keep track of our current ground angle. And what we'll be doing is checking if this ground angle is less than this max ground angle. And if it is, then we can keep moving forward. So to check for the ground, we'll need to do some raycasting. So we need to keep track of our forward. We need to keep track of a raycast hit info. And we need to keep track of a bool called grounded. So that's going to summarize the members that we add to our script for this tutorial. So we just need to add a few more functions, and I'll go ahead and write that skeleton out now. I'll add some comments and summaries of those functions, and then we can continue. Okay, so here we have our skeleton. Go ahead and read the comments as we develop if you need more information about what each of these functions do. So what I want to do now is come up to update and modify our update loop, because since we added these functions, we need to make sure that we are calling them properly. Now this check right here is really just to prevent us from moving and rotating. So I'm going to move the calculate direction function above that if statement, and all of my other functions can be called here. So again, we're only returning out of update if we don't want to rotate or move. So that's why these two functions are the only ones that need to be below this if statement. So the rest of these functions that we just added need to be placed in update. Now the order isn't exactly arbitrary, but it isn't so important that you need to make sure you're copying the exact order that I'm writing these functions. So you can sort of play around with it, but it'll probably just be easier to write these in the same order that I do. So we'll write calculate direction, we'll have calculate forward right after that. We will have calculate ground angle after that. Then we will check ground. We will apply gravity, and then we will draw debug lines. Again, the order of these functions is fairly arbitrary. If you run into issues, then you might find that switching the order of these might help you, but I seriously doubt that. So after we have that, we need to just add the contents of these functions. So how do we calculate the forward? Actually, before we do that, let's come up to move and add some code here. Remember how I said if our ground angle is greater than or equal to the max ground angle, then we can just return. We're not going to be able to move because the current slope that we're on is non-traversable ground. Now we also want to make sure that we are moving not on our transform.forward, but now since we are modifying the forward to adjust for slope, we want to move on the forward vector. Remember, we defined that right up here. So now we can come down to our unfulfilled functions and start populating that. So when we calculate the forward, we want to check first if we are grounded. If we're not grounded, then our forward should be equal to our transform.forward. And then we want to return. Otherwise, we can say that our forward is equal to the vector3.cross product of hitinfo.normal and negative transform.right. So let's talk about what those two vectors are really quickly. So back in Unity, when we do our raycast down from the center of our player into the ground, that raycast is going to go straight up. If you can imagine a line going straight up perpendicular to the ground. Then we also consider our transform.forward. So our transform.forward goes straight out like this blue arrow in front of the player. So right now you can see that if we take the cross product, we're not considering the forward, we're considering the transform.left. But for visual sake, we can consider the transform.right because that's the one that's showing up. So again, we have what we have is the perpendicular ground normal, which would go straight up into our player from here. And then we are considering the transform.right, which is this red arrow. Now, if we do a cross product on those, then we'll get the forward. We'll get this blue arrow. So really consider crossing the product of the transform.up and the transform.right, and that is how you get transform.forward, and that's universal for 3D graphics. So again, the cross of up and the cross of right will give you the forward vector, and that's exactly what we're doing with the hitinfo.normal and the transform.right. Now we're actually using negative transform.right, and that's because for us to get the correct direction, the correct forward, and this can be found pretty easily by just removing this and running it and testing that out. You'll see that when you press W, you'll actually run backwards. So just by putting a negative on that, we'll get the correct forward angle. So that's all we need for calculating forward. Now what we want to do is calculate the ground angle. So first we say if we aren't grounded, then our ground angle will just be equal to 0, or equal to 90. And we can return from that. Then we could say ground angle is the vector3.angle. It's the angle of hitinfo.normal and transform.forward. So this is what I was getting confused with a little bit earlier. So let's go back to Unity and sort of try to visualize this. So imagine the hitinfo.up, which on this plane would be similar to the transform.up. So consider this green arrow right here, and the transform.forward, which is this blue arrow. Now, right now, the angle between those is 90. So if we aren't grounded, we want to default to that angle. So that's all we need for calculate ground angle. So let's talk about how we can check ground. This one's a little bit more complicated. So we need to do a physics raycast, physics.raycast. We have the initial point, which is our transform.position. Then we have the direction, which is negative vector3.up. So that would be going down. Then we have out hitinfo. This is where we're getting our hitinfo finally for the hitinfo.normal. This is where we're getting the hitinfo for our check ground angle and our calculate forward. So the fourth parameter for this needs to be the height. And here we're going to use height plus height padding. The fifth parameter is going to be ground. That's our layer mask, which is telling us if we are actually on ground or not. So back in Unity, you'll see that if I click on the ramp or if I click on the ground, our layer is on ground. So you'll want to make sure that you assign a specific layer for your ground layer. So if we enter this raycast as true, then that would mean that our grounded Boolean should be equal to true. Otherwise, our grounded Boolean should be equal to false. Okay, now there's some more things that we need to do here, but actually what I want to do is show you what's going to happen if we just stop right here. Now, technically this will work, but when we get on, this is what we would do if we weren't considering the error of the Unity physics engine. Now, you'll see some issues arising with this, and then we'll talk about compensating for those errors with height padding. So for now, we'll leave it as is. So let's talk about how to apply gravity. Well, we only apply gravity, since we're not using a rigid body, we'll only apply gravity if we found that we aren't grounded. And to do that, it's pretty simple. We'll just say transform.position plus equals physics.gravity times time.delta time. That's all you need to do for that. Now we also have debug lines. This is going to give us some really good insight into these vectors that we're calculating. Well, actually only really the one vector we're calculating, which is the forward, and it'll also give us insight into the raycasting for checking for grounded. So to do this, we'll say first, if we aren't debugging, then we're not going to do this, so we'll just return. Now otherwise, we can say debug.drawLine. DrawLine is going to take a few parameters. The first one is the starting point. So let's go ahead and draw the forward vector. So we can start from the transform.position, and then we can go to the end point. So the first parameter is the start point, and the second parameter is the end point of the line. The end point is going to be transform.position plus forward, which is that vector that we calculated, times, and this can be some arbitrary value, but I want it to be a similar length to the height of the character. So I'll just say times height times 2. So that's just, the times height times 2 is just extending the length of this line. And then we have a color that we want to make this. So since it's based on the forward, then I'll set that to blue because that's Unity's default for the forward vector. Then we want to do a draw line for the height check. So that'll be transform.position. And this is going to simulate the actual raycast that we're doing here. So that's what I'm drawing this line for. So this will be starting from transform.position. The endpoint would be transform.position minus vector3.up, so going down times height. And the color of this can be color.green. So let's go to Unity and see how these changes are going to affect our character. Okay, so we don't have any errors. Of course, that's good. I'll make sure that I click debug, and I'll set the ground to the ground layer. So let's run this and see what we get. Okay, everything looks good. There's no errors popping up. Now let's take a look at some of these debug lines. So we can see a green one if we look closely here. So we have this green line going down, that's our debug line. You can see that's going down just the height of the cube. 0.5 is half the height of a cube, so that's why I came up with that value. And then we have the forward, which is coming out where it should be. So if we're on flat ground, the forward should be exactly equal to the transform.forward. Now let's try to run up this slope and see how things change. So we can go up the slope just fine. Let's go over to our player. Now we can see that blue vector, or that blue debug line, actually being the exact slope of the ground that we're on. So those should definitely be parallel. So that's working just fine. Now if we rotate our character, you'll see that line starts to go down a little bit. It starts to dip. So as we go down and we turn around, now our forward is aimed in the down direction. So we're always going to be moving the correct direction on the slope, the correct sort of angle on this slope. So if we're turned around, we'll actually just be running down the slope. So it works really nicely. Now we have a couple of issues you might be able to notice. Let's see if I can, okay, right here. So if we go take a look at this, our cube is a little bit in the ground. That's something that we definitely don't want. We're going to use height padding to adjust for that. Actually, height padding won't adjust for that issue, but let's see if we can get the other issue to show up. Yeah, we should definitely not be going through the ground like that. So let's address that first. So to address that, something that we can do is say, okay, if we actually get a hit, so if we're actually grounded, we can say if the vector3.distance from transform.position to hit info.point. So .point is the position on the ground, the vector3 position on the ground that is actually being hit. So if we say the distance between our transform.position and that point is greater than the height, or less than the height, sorry. So if our, in other words, if our player is sort of stuck in the ground, then that would mean that this distance is less than height. We just want to move our character up to the correct height. So we can do a lerp operation on that. So we can say transform.position equals vector3.lerp, starting from transform.position and going towards transform.position plus vector3.up times height. And we can do this at sort of a slow speed so it doesn't look jittery. And let's go ahead and just do this. Let's do this at a faster speed, and you can see some issues that come up. So all we're doing is lerping to the correct position of where we should be grounded. Let's go back to Unity and see how this affects things. Okay, so we can see that we're doing this bouncing. Now that's because we are continually trying to adjust the position to be exactly at the position that we want it to be above the ground. So this is where we have sort of the Unity physics engine error. Let's see if we can go into debug mode and see what our grounded boolean looks like. So our grounded looks steady. So this is really just up to some errors, I believe, with the physics engine. If you have some other theories, then definitely comment down below. But I actually know how to fix this because I've been struggling with it for a little bit. So let's go back to the script and see what we can do. So this is where height padding comes in. We can say that we're only checking not from height for our raycast, but from a height plus height padding. So we're actually going to do a raycast that's further than our normal raycast. And then we can say, okay, now if it's less than height, then we can move up to that. So we're giving ourselves some padding so that there's not a lot of jumping going on. So let's go back to Unity and see if that fixes things. So we're definitely not jumping now. And let's see if we can get it stuck in the ground like it was doing before. And it doesn't look like it's getting stuck. So it's definitely staying above the ground where it should be. And we can modify this padding and watch it actually, see how it actually affects it. So when I bring that back down to 0, we get that jumping again. Now, it's safe to say that our character will probably never go below the ground. Let's put this up to 0.01. And even with a small value, it sort of fixes the problems. But when we go up and down slopes, we can see that jittering happen every now and then. So this comes down to a tweaking, and it's probably going to need to be tweaked based on your character. So let's bring that up to 0.05 because that value seems to work pretty well. And let's see if we see any jitter. And I'm not seeing too much. So it's looking pretty good right now. Now for the ultimate test, that is bringing it to this really crazy terrain. This terrain isn't something you would probably be traversing on in an actual game. So it's really good for stress testing something like this. Now let's set our max ground angle to 0. And that's going to allow us to just go over, or I'm sorry, let's set it to, instead of doing that, let's go back to our code and make sure that that max ground angle isn't affecting anything. Or no, instead we can let's just ramp that up. So max ground angle is 180, which means we should be able to go on any terrain that isn't totally perpendicular to our forward. So you can see how we're going up this, pretty easily. There's definitely some jitter because this terrain is so different from one point to the next. And so now we're seeing how some stress testing can allow us to optimize this controller. Now, believe it or not, just by modifying our padding, we can resolve a lot of this jitter. And that's why it's such a cool little value to have in this script. So since this terrain is so volatile, let's bring that height padding from 0.05 to 0.25 and see how that changes things. So it's a lot smoother now. Looks very nice. Now, some of you might be catching on, and you'll be able to know that it's not the perfect solution. The reason for that is because let's come over here and fall down on this plane, and you can see that we are elevated above the ground a little bit. And we're elevated above the ground because we have, we can see our green line inside the cube. That's going to the correct height, but we're elevated, and that's because that's going to be our height padding. So we can create another debug draw line to show that height padding. But essentially what you want to know is that this height padding is going to, since it's being incorporated into the physics raycast function, it's going to also dictate how high your character sits off the ground. So if we sort of bring this down slowly, you can see that we come down to the ground. So maybe something like 0.15 would be better, because when we're on flat ground, it doesn't look too noticeable that we're off the ground, and it might also still be smooth on that really volatile terrain. So let's go back to this terrain. And considering the volatility of this terrain, the character isn't jittering that much. So I do believe that it would work very well on some smoother slopes. Now let's modify this max ground angle. You can see I'm in debug mode. I got there by clicking on this little bar up here. We can go from normal to debug. Debug is going to show us our private members in our script. So we have this ground angle. Right now it's at 90 because we're on flat ground. And we can see, let's say we don't want to be able to go up this slope because it's too steep. So we can just go right up to it and look at our ground angle. That's 145. And then we can say, hey, let's make our max ground angle that angle. And then let's try to run up it. So then we stop. Now, there is a little bit of an issue, and this is something I see in several games actually, where if you're going sideways, you can still run up it. So that's not something I'm going to cover in this tutorial, just because it would get too long. But if you guys want to talk about how to do something like that in the comments, feel free. We can definitely discuss that. But that's going to close things up with this tutorial. We went through a lot, but I hope you guys learned something, and I'll see you in the next video.